This is Unit 5.8, Graphing Absolute Value Functions. We are going to learn how to graph an absolute value function and then how to move that graph around to different positions, translate it. So shift it left and right, up and down. Here's an example of a translation. So here you have the graph on the left of the absolute value of x. And absolute value means a couple different things. It means distance from zero. So just to review really quickly, like if we were going to make a table of x and the absolute value of x, if x is -3, the absolute value of -3 is 3, because -3 is 3 away from 0. Also, if we were going to do like -2, the absolute value is 2. If we did +2, well, that's still 2 away from 0. So you'll notice the absolute value function always, if you had like the number 10, it would be +10. It always gives you a positive number on the output. And that's what we see here in the graph as well, is that as x is like -2, the output is +2. As x is -4, the output is +4. And so this graph of the absolute value function is always positive. It kind of looks like it comes down and bounces off the x-axis and then goes back up. And that is the most basic absolute value function of just y equals the absolute value of x. Now, on the right, we have y equals the absolute value of x minus 2. And you'll notice the graph looks the same. It's the same shape. But now it's moved down. This point in the original graph, it was at the origin. We call this point the vertex of the graph. And the vertex has shifted down too, and so has every other point on the graph. So in the original graph, we had the point -2, 2. And in the translated graph, that has been moved down too. It was up here, it moved down too. Same thing on the other side. And any point on this line on the left got moved down to, or translated down to, when we did this -2 to the equation. So if we looked at this graph, we would say, hey, that is the graph of the absolute value function, and it is translated down 2 units. If somebody asked you, how is this? If somebody asked you to describe how this graph is related to the graph of y equals the absolute value of x, we call this the parent function because it doesn't have any changes made to it. And then the children are similar to the parent, but they have some changes. They're slightly different. Like this one has the -2. That -2 has translated the graph, or translated the graph down 2 units. An interesting thing to notice is that, whoa, that is not what I was trying to do. What is the slope? Well, this happens to be what we would call a piecewise function, because on the left side, you have a slope, m equals -1. This side has a slope of -1. And on the right, if you look, it goes over 1, up 1, over 1, up 1, over 1, up 1. So its rise over run is 1 over 1. This slope is +1. So on one side you have a slope of -1, and on the other side you have a slope of +1. Let's look at a couple more. And what we need to be able to do first is we need, sorry, I'm having a little bit of technical difficulty. Is that right? We need to be able to describe how each graph is a translation of the parent function, the graph of y equals x minus 2. Oh, I don't think I quite finished explaining. Now I have a nice clean graph, so I'm going to do it. This is piecewise because this line right here would have a different equation. The equation for this side would be y equals x. And the equation for this side would be y equals -x. So actually the graph of y equals the absolute value of x is composed of two different functions. So we say it's piecewise. Oops. We say it's a piecewise function because it's made up of those two things. It's made up of two pieces. One piece is the y equals -x, and the other piece is the y equals x. All right, but the important thing is that we can describe how each graph is related to the graph of y equals the absolute value of x. And we're going to use the word translated. And so for this first one, we would say that this is, well, normally the vertex would be here, and now it is over. We can see right there is -2, so this must be -1. So this has been translated left. Oops, better write the important word. It's translated left, and translated means moved but not changed in any other way, just like slid over. Translated left 1 unit. If we look at this graph, this next one, well, normally the vertex would be at the origin, and now we are 1, 2, 3 to the right. So this one we would say is translated right 3 units. We don't have any like feet or inches or centimeters, so we're just going to say units. It looks like my U's and my N's are exactly the same. That's too bad. Now in this third graph, origin is here, and our graph has been moved up to 2. So this has been translated up 2 units. Okay, so on the next slide, you're going to answer these questions. You're going to describe how each graph is related to the graph of y equals the absolute value of x. We call this the parent. So in other words, we're going to describe how each one is related to the parent function. Yep. So you just say translated and left or right or up and down and how many units it moved. Easy peasy. And then we'll look at how we write those equations once we've done that.